Thank you for coming to the session today. I'm Mark Fisher. I'm an engineer at Pivotal. And today I'm joined by João from Google.
Hey guys, I'm João Martins. I'm a software engineer for the Cloud Java runtimes and frameworks in the New York office. Before that I was based in Sydney, and before that I was based in Ireland. Just quick about myself. And we're here today to talk to you guys a little bit about the project that we've been working on, which is called Spring Cloud GCP.
Okay. So the goal with this project is to make it as easy and seamless for Spring developers to use the services that are available from the Google Cloud Platform. And so this means not only for existing Spring users to be able to experience the same idioms that they would expect with other services, but also for new users to just Java users of the the Google Cloud Platform to have the simplest possible experience actually using services like PubSub and cloud storage. And many of these will be demoed today by João.
That's right. So at Google, we've been doing this cloud thing for a long time internally. We've been doing it mostly to handle the scale of some of our services like ads and search. Sorry. So we realized that Spring was actually the most popular Java web framework. And we basically decided that we had to meet our users where they were. And that was kind of like the idea to get into this partnership with Pivotal. And we decided, okay, we have to bring some of this Spring goodness into GCP, like cutting boilerplate code. You'll be familiar with some of the products here. We've got App Engine, which is how we started our cloud business back in 2008. So we've also got Kubernetes. We've been hearing a lot about it in this conference. We've got GKE, Kubernetes Engine, which is probably going to be the source of many interesting integrations in the future with PKS, Pivotal Container Services, which we've also been hearing a lot at this conference.
Yeah, and we're also running the Pivotal Function Service on PK. Will be running on PKS, and that's also going to be running on Kubo. And since the Riff project that I just announced in the keynote is going to be running anywhere on Kubernetes, we run that on GKE as well, just natively. Mm-hmm. So this project actually got kicked off in the second quarter of 2017 between the Java Runtimes team in New York primarily and a few of us from the Spring team. And it's been a really good collaboration model for us because they've actually written most of the code, and we've been in a role of as reviewers, which is really the ideal model for us because they know their services best and how to most efficiently configure those, what options to expose for users, and so on. And we know the Spring idioms best, and so we can kind of review from that perspective when it comes to things like naming, which is always the most important thing, right? So naming and where the camel case goes, and all the way down to details like how a boot starter should be ordered and things like that. So we've been playing that role, and it's been a really successful collaboration. And I think a lot has been accomplished, but there's still probably a never-ending list of more integrations that we can do across the slide that you just saw.
Yeah, for sure. We've got you guys have got also our project page that I really welcome you to go check out if you're interested in the project. You can find useful resources there, such as our reference document. Just our releases, tutorials, getting started guides. So it should be kind of like your first stop whenever you're looking into our project.
And the thing I want to point out here also is that these projects are actually hosted in the the Spring, the Cloud Spring project page, the Spring Cloud org on GitHub, right? So these are projects that are being maintained as a joint effort between Google and Pivotal and the Spring team. So the focus primarily has been on Spring Boot as the starting point, right? So like if we were doing integration with services 10 years ago, we probably would have had to do a lot more work in terms of configuration and maybe XML parsing and things like that we don't worry about today. So it's nice that that's been able to be the focus from day one. Building Spring, the way you would primarily use Spring Cloud GCP is to add dependencies to your POM that bring in Spring Boot starters. And how many people have used Spring Boot? It's probably, this is, all right. I guess we're at a Spring conference, and it's 2017, so you can expect that. But don't need to go into much detail on that. Just to point out that Spring Boot allows you to drastically reduce the amount of configuration boilerplate in the same way that Spring Core libraries reduce the code boilerplate. And so that's, in a lot of cases, using these Spring Cloud GCP projects will just be a matter of adding a dependency, and then your code might be the same. For example, you'll see in the demo with this Spring Cloud Resource Abstraction for Google Cloud Storage that your code can literally be the same as it would for any other resource using Spring's library. It's just the URL that changes and the dependency to add that. So that's just one example. We'll see a few more in the demos.
Yeah, for sure.
So we just had the Milestone release. What was that, a few weeks ago?
Yeah, end of October, I think, yeah.
And that's the first milestone. I will say also that this project has very good documentation and for a first milestone. So you really can go check it out now and start using it. The artifacts are in the Spring repository, the Milestone repository, which if you're using Spring starters, then you get those repositories added to your POM automatically. And we do have a pull request open for support within Spring Initializer to have the checkbox feature. So you'll see as the demo is proceeding where that would be, make it slightly more convenient, and that will be on the way probably by the time many of you get a chance to try this out after the conference.
Yeah, cool. Yeah, so that was all about the slides. Yeah, now I would like to guide you all through the flow of a normal Spring Cloud GCP developer and do essentially a live coding demo where we're going to use some of the integrations that we've built. So essentially, the problem here is to build a real estate sales platform. We want to sell houses on the internet. And so in order to do that, I came up with a few requirements, 3 requirements, and we're going to use one integration for each. So the first one is essentially we want to have a database. We want to be able to store houses in our database, read them, do normal CRUD. The second requirement is that we should be able to notify real estate brokers, so real estate salespeople, that we've got new houses on the market so that they can go ahead and essentially start selling. And then the third requirement is to be able to store the pictures of what we're selling, because there's really no point for a real estate sales platform to exist without pictures, because people don't know what they're getting. So cool. So for the first part, to store our houses, I was actually thinking we could just go ahead and use a Google Cloud SQL instance and use the Spring JDBC integration that we've built. This essentially enables you to use Spring Data JPA, which is pretty popular. I saw in some presentation that it was like over 60 or 70% of the dependencies on Initializer. Yeah. So you might be familiar with it. Yeah, so why don't we get started? So I'm going to leave Preso mode. And I'm actually going to go here. So, OK, so first thing, actually, I'm just going to go ahead and start the incognito window. So the first stop, basically, for a GCP customer is to have their GCP project ID. So that's what I'm going to do now. I'm going to go to our Cloud Console. Wi-Fi, please don't let me down. I'm on the right, yeah. Oh no. So this is a very interactive demo, and yeah, Wi-Fi is unfortunately letting us a little bit down. If you reckon. All right, so just some live debugging over here. Oh, there we go. All right, and I am going to use one of these credentials that we're actually giving out at our GCP booth. Nice. So I recommend you folks to go to our booth after this session and try out some of our other code demos there. And I'm going to go ahead, and log in as this user. So start routine at GCP Lab. All right, we're almost there. All throughout the conference, I've been able to just access the Cloud Console. Yeah. All right, it had to happen. So, okay, all right. So. Cool. So we've got our project here. This is a project ID, and or this is a GCP project, and we're going to use SQL. So we should probably just go ahead and create a SQL instance. By the way, is the font okay for people on the back? Maybe I should increase it a little bit. Yeah, sorry about that. Oh, wider? You think? I'm just going to try and reconnect again, see if it works. Just got reconnected from the Wi-Fi again. Might be able to actually. Cool. All right, hopefully we go a little bit smoother now. All right, so yeah, we are going to create our instance. So we're going to create a MySQL instance. But this is basically asking us if you want to create a second or first generation. We create a second generation because first generation is legacy. So for our instance ID, I'm just going to go ahead and call it Spring 1-houses. Just for this demo, I'm not going to set any password. And we can leave the other options just as default. Just go ahead and create it. All right, and while this is creating, I'm also going to go ahead and get started on the code. So we're going to use Spring Initializer. So you can use Spring Initializer from the website, or you can also use it from IntelliJ. I'm going to use it from IntelliJ. All right, we're going to call our application houses. And as for the dependencies, we saw that we want to use JPA. Now, as Mark mentioned earlier, ideally, we would have our Spring Cloud GCP dependencies on Initializer. We should be able to get them right after Spring 1. We should be able to get the dependencies in. So for now, we're going to have to add them by hand.
And that also means that the dependencies can pull in their transitive dependencies as well. So it should be a single click for a feature at this level, like Cloud SQL.
OK. So the first stop for any Spring Cloud user should be, besides our Cloud Console, should be our reference document. And as I mentioned earlier, you can actually access that from our project page. So that's what I'm going to go and get it from. And what we want to do is we want to get our starter dependency into our pom.xml. So we're going to go ahead. We're going to go choose Spring JDBC. We're going to copy and paste this.
You might want to increase the font size.
Oh, that's right, yeah. Is this good? Let me know if you want me to increase it a bit more. All right. Cool. So we've got our starter on pom.xml. Besides the starter, we'll also need to add the pivotal Maven repository because we're still on Milestone release, so we still don't have our artifacts on Maven Central. We're planning to have them there very soon, but for now, we're going to have to also add it there, and we can actually go to our GitHub page, and we can also copy and paste it from there. And one last thing, if you notice, our dependencies don't have any versions, and that's because we're actually using the Spring Cloud GCP BOM to do the version management. So we can also just go ahead and copy that from GitHub.
So this is also a common pattern for those of you who have used libraries within Spring to be able to basically create a release train when there's multiple subprojects and manage the dependencies in a single place.
Mm-hmm. Cool. All right. So let's jump into the code. So as we said, we want to have a real estate sales platform. So we want to sell houses. So what is a house? Let's declare what a house is. So we have a house. Our house has an ID that we're going to say it's a long, and it has an address. We'll go ahead and create the constructors. And we'll also create the getters and setters for what we want, which is just the address. We'll say that the ID is our primary key and that it's a generated value. And then we'll say that house is our entity. Yeah. Is it good? All right. And for those of you that are familiar with the Spring Data JPA, there's this very neat thing that you can do, which is you can declare an interface. We're going to call it a house repository. that you can say extends a CRUD repository to allow us to do that CRUD stuff, create and stuff, update. And we're going to say that our house repository is storing houses and that the primary key is a long. So what Spring Data JPA is going to do is it's going to detect this interface. It's going to generate the code for an implementation, and then we can just inject an object of house repository type, and it's going to be kind of magically working. So in order to run our code, I'm actually going to use a Spring trick, which is the command line runner. So this essentially is going to be run after our Spring application is run. And there we go. So yeah, so we want to store houses. So as I mentioned, we're going to inject our house repository. And then we're just going to create a few houses. So never mind the error, like it should be fine. So okay, so let's create a few houses. So all right, I'm going to go ahead and sell, put up for sale the Google New York office. It should be pretty profitable. So that's 18 Ave, New York. All right, so I'm planning to make good money from that. Who else wants to put a house for sale? Mark, you wanna put something for sale?
The Pivotal office is right around the corner.
Pivotal office, do you know the address?
Oh, well, this one, sure, why not? I was thinking New York. But
Which one? 875?
Yeah, might as well.
875, which street?
Howard.
Howard Street? Okay. 1600, I like it. Actually, it's embarrassing, but I don't know how to write Pennsylvania. Is it like this? Gee, okay, and a Y? Is it a Y?
There's a Y after the S.
No, there can't be like, is it this? No, it's not this. I don't know. All right, cool. Is it this? It can't be this. Well, whatever, doesn't matter. It's two Y's, I don't know.
Two N's here. And then
all right, homework.
One N and then an I. Is that it? All right.
All right, after this talk, I'm going to go ahead and brush up on my geography skills, yeah. OK, and someone said North Pole. Why not? I mean, there's buyers for stuff on Mars and the moon, so. Cool, all right, I think we're good. So we've got all these houses, we need to start them. So for each of these, we're actually going to go ahead and save them. So, all right, so we're saving them just to make sure that everything's working. We're actually going to go ahead and read them and just log everything. So.
So it's probably pretty obvious to most people, but so far, nothing that he's done has been specific to Google. We're creating an entity object, creating a JPA repository, calling load and calling save. So this same code could be run in a truly portable way.
That's right. Cool. OK, so that's it in terms of the code to create and read our houses. So we still need to basically tell our starter where our instance is. So using Spring Data JPA, the general version, you need to know things about the JDBC URL, the JDBC driver class. So our starter actually takes care of all of that for you, so you don't need to know any more JDBC URLs, stuff like that. What you do need to know is your instance, your Cloud SQL instance ID that we call the instance connection name. And you can actually get that from the Cloud Console. So we have our instance, it was created. And then if we scroll down, we have this thing, instance connection name. We can just copy on this thing. It copies it. Click on this thing. And we paste it here.
You might want to increase the font size here, too, so you
yeah.
can see the name of the property.
OK. And then, so yeah, the instance connection name, and we'd also need a database name. So we'll quickly create a new database from the Cloud Console. We'll call it houses. Cool. And yeah, that should be it. Just one more thing. I don't know if you noticed, we haven't really created any schemas for any tables or anything like that. For the purposes of a demo, I'm actually going to ask Hibernate to do that for us. But obviously, for your production app, you should probably go ahead and declare the schemas of your tables so that you don't get any unpleasant surprises. OK, so
often this property would be specified with a profile, so you're only actually dropping tables in your development instance and not production.
That's right, yeah. So yeah, and before we actually go and run this code, we'll also need to authenticate. So to do that, for this demo, I'm actually just going to use the Cloud SDK, and I'm going to run this command, gcloud auth. OK. And this essentially will take care of the authentication for us. So this command saved the credential token to this location here. And our starter will be smart to get it from there. So we actually don't need to worry about this. Again, for your production app, you will probably want to create a service account. You'll want to download the private key and store it somewhere safe. So just saying. OK, so yeah, I think we're all good. Let's try and run this app. Let's create a few connections. OK, we ran, so let's see. Yeah, here we go. We have all of our houses here that we put up for sale. So that means that they were stored, and then we retrieved them, and we printed them. So yeah, just to recap what we did here, we added our starter to our POM XML. We configured the access to the instance just by giving this instance connection name and the database name. And we just ran pure generic Spring Data JPA code, no knowledge of Cloud SQL whatsoever. Yeah. Yeah. So we didn't really need to open our instance to any IPs on the internet, and that's because the way our starter works is you authenticate with Google, and then Google tunnels you to the instance. So that should be cool. Your instance doesn't need to be open to the internet. OK, cool. So I think that takes care of the first requirement. So yeah, let's move on. So now we want to notify salesmen that we have new houses for sale. So we want to message them. And what I suggest we use is we use Google Cloud PubSub through the abstraction that we created in Spring Cloud GCP. So we'll have our app. Our app is going to be publishing messages to a Google Cloud PubSub topic. And there will be a number of brokers or a number of salesmen that are going to be listening to subscriptions associated to that topic. And they will get our new houses. So yeah, let's go ahead and code that up. So first thing, we want to start publishing the houses. and we want to use PubSub. So let's go ahead and get our starter. So we go to the reference document, copy the dependency, paste it there. All right, now this dependency gives us access to a powerful abstraction that we call the PubSub Template. And now, instead of just printing the houses, we actually want to publish them to a topic. So we'll use PubSub Template, and we'll use the publish command. We'll specify a topic. Let's say we want to send them to a topic that's called new houses. The payload of our message is going to be the address of the house. And we won't want to send any headers, so we can just go ahead and say null here. And yeah, that should be enough. So in terms of code, I mean, we're still going to need to tell our starter what our project ID is. And we can get the project ID from the Cloud Console again. So you can go to the home page, and this is what we're looking for. All right, so basically publishing to PubSub is as easy as this. Now, we're going to go ahead and, no, I don't want to update now. So we have the main app that's publishing the houses. Now let's go and code a broker that's going to be receiving these houses. So we'll use Initializer again. We'll call it broker. We don't need any dependencies from Initializer right now.
And just to be clear, when you say broker here, you're referring to a real estate broker.
Yeah, yeah. So not like a
broker.
service broker or anything. Yeah, that's a good distinction. Yeah. Okay. All right. So let's do the same thing here. First, we add our starter, and I'm actually just going to go ahead and copy it from here. And besides that, also add our repository and our BOM. Yeah, let's enable auto import. Sorry. All right, so now that we've got it, okay, font size a bit bigger. We'll use the same trick to run code. We'll use the command line runner. Just call it listen. Cool. So yeah, we will need the PubSub template to subscribe to subscriptions. So that's what we'll do.
So this is an example where some of you may already know this, but the PubSub template is going to be injected, auto-wired into this method since it's a configuration method. And the PubSub template is itself being created by the starter. So there's no explicit bean definition necessary.
Exactly, yeah. You get an object that kind of just works, yeah. Yeah, so we'll call our subscription new houses - broker1. If we want other subscriptions to be listening to the same topic, we can we could call them broker2, broker3. We can call them whatever we want, or not even new houses. It doesn't need. There's not like really any convention or anything. And okay, so we've got the subscription, and now we'll need to declare this message receiver, which is essentially what's going to be triggered when we get a new message. So that's essentially a Lambda that's composed of a message and a consumer. Now, the consumer, we're not going to really need for this demo, so we don't need to worry about it. And what we want to do here to process the message is just log it. So we'll do the same thing that we were doing before, so system.out.println. New house for sale. And we'll get the payload, and it's a string. All right, so in terms of code, this should also be it. As we did before, we need to tell the starter what our project ID is. So I'm also going to copy that from here. OK, so we're almost there. The last thing that we need to do is actually go to Google Cloud PubSub and create this topic and this subscription. So let's do that right now. All right, so we'll create a topic. If you guys remember, we call it new houses. And we'll add a subscription to this topic, which is new houses-broker1. We can leave the rest of the settings by default. That's fine. Cool. So now our infrastructure is in place. Let's go ahead and start the broker. Our broker started. And then we can also start our main application. So the main application is starting, creating a connection pool to Cloud SQL. All right, so something happened here. And yeah, so we can see that the broker actually received the houses that were sent by the main app. So yeah, so this also works. So just to recap, what we did here was to add the PubSub starter to our application. We told our starter which GCP project ID to use, and we just used the PubSub template and just use this subscribe and publish calls to kind of subscribe and publish to Cloud PubSub. So I think that's pretty...
Yeah, so one thing I wanted to just point out here, unlike the SQL example, which was completely vanilla generic code that would work against other relational databases, this is using a specific template implementation for the Google Cloud PubSub. But that is basically, from a consistency perspective with the Spring portfolio, that is at the same level as things like Kafka template and Rabbit template and even JMS template. Right? So the idea was to model that layer and expose that to users who need to work at that level, and to demo it as something that is directly connected to the PubSub template. Above that, though, there is also integration, Spring integration support for that, so that you can have channel adapters that abstract all of that away for you and just rely on the message listener interface at the Spring integration level. We were talking about that in terms of how this demo was being prepared, and it seemed like it wouldn't be quite as satisfying if the entire demo had nothing that was actually Google specific in it, but it is possible, and that's often what we would do. So
yeah.
Just to make that clear, there are those two layers.
And if you're more interested in our Spring integration channel adapters for Google Cloud PubSub, you can always go ahead and visit us at our booth. We have some code demos there, and there is one that uses the PubSub channel adapters. All right, so the second requirement's done. Now let's jump to the third one. So yeah, so we want to store house pictures. And for that, what I suggest is that we use the Spring resource abstraction backed up by Google Cloud Storage, which is where our starter comes in. So I'm not sure, does anyone here know what a Spring resource is? Raise of hands. OK, all right, so it warrants an explanation. So a Spring resource is essentially an object that has an input stream, and it can represent several things. It can represent a file on the class path. It can represent a file on the file system. It can represent a URL on the internet. And what our starter does is it adds another option to all of these options. It makes a Spring resource also be able to be a Google Cloud Storage file. And we're going to see how that works.
And so this, even though not everyone was familiar with the resource abstraction, everyone who uses Spring is using the resource abstraction all of the time because it's deep in the core. every time things are being resolved off of URLs. And it's been in Spring from the very beginning. It's a useful abstraction, and it allows you to externalize your URL, basically, and just change the scheme for a URL to be able to add support for Google Cloud Storage, S3 buckets, and so on.
That's right. So, yeah. So again, first thing we do is add our starter, our Spring Boot starter. So we'll add that to our dependencies. That's it. And cool. So what we'll want to do now is we'll want to save a house for, let's say, Google New York, our first option. So we'll want to get the house from we'll want to get a picture of Google New York, the Google New York office from the internet. We'll want to copy it into a Google Cloud Storage file, and we'll want to save the location of the Cloud Storage file with our house object. So let's go ahead and search what Google New York looks like. All right, so I guess we can just use this one. Yeah, so yeah, we're going to have a resource. No, that's not what I want. Okay, and we'll want to load this resource. Now, in order to load it, we're actually going to need the Spring application context. So we'll inject that. And then we'll use it to load our resource. So get resource. So essentially, I just paste the URL here. And what it does is Google Picture now has a input stream that's going to give us the bytes from the content of this URL on the internet. And we also want to have our GCS picture, which is going to represent the GCS file. So in order to address a GCS file, really the only thing we need to do is use the gs:// protocol. And we need to specify our bucket. So I'm just going to call it spring1-houses. And the object name, so google-nyc.jpg. All right. And
so I think those two lines really demonstrate what we were saying, that there's no difference in the code there. It's only a difference in the prefix, right? So the same code that Spring uses to load HTTP can be used for cloud storage. You could also have injected just the resource loader instead of the full context. But.
Oh, that's right. OK. All right. So yeah, now we want to copy the picture from the internet into cloud storage. So the first step is to copy the picture from the internet into memory. So the way we do that is we have a byte array. And we'll give it the internet input stream. Cool. So this essentially copies the picture from the internet into our memory. And then we'll want to write that to GCS. So the way we do that is by using a Java resource. So output stream is, we're going to cast it to writable resource in order to have an output stream. And yeah, now we just need to write to that output stream. So write. Cool. So essentially, accessing our cloud storage file is as simple as this, essentially. And yeah, so now we'll
it could be simpler as well with the utility class, but I think this demonstrates what's actually happening better. So it's good for the demo.
Cool. So now we'll also want to start the GCS URI with our house. So we'll need to add that to the house model. So yeah, we'll also add a constructor.
another thing while he's adding this with resources, when you're setting boot properties and one of the targets that you're setting is a resource, you can pass just the string of that URL as the value for that property, and it will be injected as the resource object. So that comes in handy as well for things that you want to configure, like maybe some file that you need to use at startup time, right?
Yeah, that's right. Some of our starters actually make use of resources to locate some properties. Cool. Okay, so in terms of code, I think we're all good. We just have one last thing to do, and that is create this bucket, which is Spring 1-houses. So we'll go to the cloud storage. We'll create a bucket. And I hope that no one in the audience created this already. All right, no. Because actually, the GCS bucket namespace is kind of unique. So from the point I create this bucket.
So normally you should create your bucket before you write your code then, right?
Yeah. That's right. OK, all right, cool. So bucket's created. And yeah, I think we're good to go. So let's give this a shot. Started. It's OK. So yeah, we've got our google-nyc.jpg blob here. Let's go ahead and download it. And yeah, it's the same picture that we Googled. So yeah, so to recap what we did here, we added our storage starter. And we addressed our resource in this very, very simple way. So again, no GCS-specific code. This is all Spring. And yeah, so hopefully, so yeah, so I think we've got our third requirement down. And yeah, so so before we did this presentation, there were a few other, we've got a few other integrations also ready, but unfortunately we didn't have enough time to demo them here today. So it would be really cool if you guys come in and check them out by yourselves. But just this one that I would like to talk a little bit about. So we have a Spring Cloud Sleuth integration with Google Stack Driver Trace. So if you have a distributed application, or if your application does HTTP requests, and if you want to capture those, try to see how they're performing, you can actually add our starter, our trace starter, and just by adding the starter, your Spring application will actually start generating traces and saving them to Google Stack Driver Trace. So you can go to the Cloud Console and you can have a view of your requests like this, which I think is pretty cool.
Another example, I mentioned earlier Spring integration as a layer above the PubSub template, and we're also starting work on the Spring Cloud Stream Binder implementation for PubSub that is sort of another level beyond that, which would allow us to run Spring Cloud Stream apps as well as Spring Cloud Dataflow on Google Cloud Platform and make use of the PubSub messaging for the binder. That's right. Cool. So yeah, that's everything that we had for you today. You've got, again, there are the links for our GitHub repository there and our project page there. It would be great to have feature requests from you. If there's any integration that you need, we want to build it for you. Please go and give us some stars at our GitHub repo. Come down to our booth, talk to us, do our code demos, and yeah, I think that's all we got. All right. Thank you.
All right. Thank you for coming.